Alright, chemists, so let's have a look at the rearrangement of atoms in a chemical reaction. And basically, with this lesson here, we're talking about what happens inside the arrow. This is your vocabulary. If I just get you to pause the video, write this down, and yeah, we'll continue from there, just so you've got this to refer back to as we move along. So, chemical reactions. Now, a chemical reaction is a chemical change, which means a new substance is formed. So the law of conservation, though, says that matter cannot be created or destroyed. It can only be converted from one form to another. Thus, we can't create new atoms, but we need to move those atoms around to create our new substances. This is also known as the first law of thermodynamics. Really important to understand that this is why we have stoichiometric ratios. And those stoichiometric ratios, they are conserved. And they're conserved because we can't create or destroy matter. We can only move it from one type to the next. Our example here is 2 magnesium atoms plus 2 oxygen atoms, although they are bonded together, gives us 2 molecules of magnesium oxide. Now, the stoichiometric ratios there, we have 2 magnesiums on the reactant side, 2 magnesiums on the product side, 2 oxygens on the reactant side, and 2 oxygens on the product side. But what we end up with is for every 2 magnesiums, we need 1 oxygen molecule, and for every 2 magnesium atoms, we'll end up with 2 molecules of magnesium oxide. So what we can see there is that the numbers of atoms are the same, on both sides of the arrows. So this means that it's a rearrangement of atoms. And here we have hydrochloric acid plus zinc. And this gives us zinc chloride as an aqueous solution and hydrogen gas. So if we look at over here, we've got the two acids, the 2 hydrochloric acids, in solution. They would be separated, but we've put them together both for space and to show that one molecule is being rearranged to another, and zinc solid. And that one zinc solid will now attract 2 chloride ions, which chlorine atoms with with an extra electron, and we'll lose 2 hydrogen particles. 2 hydrogen atoms as 1 molecule of hydrogen gas. And we can see that the atoms are the same on both sides, they're just rearranged. So to get there, we need to look at something called activation energy. And this is the energy inside the arrow. For a reaction to occur, I don't know if you've considered this, but molecules, including elemental ones, they need to be broken down into the atoms that they're made of. They'll be all separated out. So constituent atoms become quite separate. The energy required to do so, well, we call this the activation energy. Now, once all the atoms are separated into their own separate little atoms, they can be rearranged. And that looks like this on an energy diagram, an energy profile, we'll call this. So on the y-axis, we have energy. On the x-axis, we have time. So we have all the energy stored in the bonds of the molecules. Just here we see we have a molecule of orange and purple and a molecule of light blue and red. We then reach the activation energy, and all of those molecules are separated into their own separate atoms. And then they reform. So they drop back down in a less energetic state, and we see that the energy is now stored in the bonds of the new molecules. Also, there's more energy stored in the reactants than there are in the products. So that means energy will be released into the environment, and we call this an exothermic reaction. So I hope that made sense. If you have any questions, put them in the comments below and we'll get back to you as quick as we can. Please subscribe, and that way you'll keep up to date with all the chemistry action coming from us. Thank you. Bye now.